Hi, Bobby.
Hi, Aniruddhan. So we have the nice table available with f of t and corresponding f of s.
Yes.
We have u of t, tu of t, all that. Cos omega t, sin omega t.
Mm-hmm.
But something is missing.
What is that?
See, usually circuits I will have some phase also.
That's true. We saw phasors, they come
Yeah.
with phase angle and so on,
Correct.
right?
So if I have sin omega t plus phi,
U of t.
yeah.
Okay, I see. Hmm. So we need to find out the Laplace transform of this.
So I have to derive whole thing. Or
Hmm. Let's see if we can try to use some property, no? Well,
what we know is
we know the Fourier.
sin omega t, cos
Correct,
omega t individually we know.
correct. We
So
know
we should
for
be able to
these
manage
two.
with that somehow.
Let's try. Maybe we can use some trigonometric property, no?
Uh-huh. What is that? So what you're saying is sin omega t plus phi.
Shall we try expanding this?
Let's try. So that is sin omega t
Cos phi.
cos phi plus cos
Omega t sin phi.
Okay.
Oh, okay.
So, that simplifies.
Yes.
Because these two we know how to write.
Correct.
Okay. So that means f of s.
That's right. So the Laplace transform of this.
Straight away we can write.
Yes.
Laplace transform of sin omega t.
Sin omega t.
That's
so that is
omega by-
omega by s square plus omega square.
Cos phi
Cos phi.
plus s by
S by s square plus omega square times sin phi.
Okay.
Oh, this is straightforward.
Okay. Oh, this is not as complicated as I
Yes.
thought.
Yes.
So I can.
Okay. And they can do, students can do for cos omega t plus phi.
Yes.
That's now very straightforward.
Yes.
Very easy.
So I'll fill the table here.
Yes.
I wanted to fill everything here. So.
Yes.
Oh, so it was
Omega cos.
omega cos phi.
Yes.
Omega cos phi plus yes
S sin phi.
sin phi by s square plus omega square.
Yes.
So cos phi should be very similar.
Yes.
Homework. Otherwise, it will be too boring for.
That's right.
demots.
We can keep saying no for
Yes.
lots and lots of functions.
Correct.
But whenever we use it, they can always go and apply the
Yes.
requirement
Yes.
and for the Laplace transform.
So what shall be next? Somewhere I think we have done u of t minus a.
That is true.
shifted by time.
That is true. Yes.
Can we somehow have a generalized form?
Sure.
For example, if we have f of t minus a, u of t minus a,
U of t minus a.
and what
Yes.
shall I write?
So just like we had sin omega t u of t and so on, we can have f of t u of t. Now we are shifting that.
Yeah,
Right?
shifting in time. I
In
think
time. We did that.
Yeah.
U of t minus a is just u of t delayed by a time a,
Okay.
which means it goes steps from 0 to 1.
At time t equal to a.
Correct. That's right. We have done that. We have
Till
looked at
dot
it.
is 0.
Correct.
That's what I remember. Okay, so this we need to somehow.
Okay.
So I have f of t minus a, u of t minus a.
Correct. So the Laplace transform of this.
Anyway, I'll write the standard equation.
Yes.
F of t minus a raised to minus st dt.
Yes.
So you were saying that this is 0 till
Correct.
time t.
Till time
right?
t.
T equal to a.
Correct. Till the time
So,
a.
So we'll change the limit or?
Yes, because it is anyway 0 for t less than a.
Okay. So that becomes a to infinity f of t minus a
Yes.
e power minus st dt.
Yes. Because u of t minus a is 0 till a and 1 beyond that. So once you change the integrals from a to infinity, it is just f of t minus a. Correct.
Yeah, equation is correct, but how to go forward is
That's right.
not very straightforward to me.
So shall we try something?
You want to generate some t minus a?
Yes, maybe we'll just change the variable. So shall we set tau equals t minus a? Shall we do like that? Then we can say it will become f of tau. It's a little bit easier to handle.
So what you're saying is, you finally you don't want this e raised to minus st here.
Correct.
If that is also some t minus a, then it's
That is correct.
easy.
Correct. Maybe we can do that right now.
This also.
Yes. So maybe we can. So first that e power minus st, no? I think we can do that. Convert it. We can multiply and divide by e power minus sa. E power sa. That might help.
E power sa.
Sa. And divide also by e power sa. I think that will help, no?
Oh, because I cannot just multiply to divide.
You have to divide also. And this I think e power minus.
That's to get t minus a.
Right. You pointed out that you wanted t minus a
Yeah,
there.
yeah, but you are very smart. Yeah. So let's get that means
A to infinity.
a to infinity f of t minus a e power minus s into t minus a
Yes, correct.
dt.
Correct, dt. And then
So this one I will.
you can take it outside the integral. It is not a function of t.
Anyway, that guy has no other
Correct.
role there.
Correct.
So e power
Minus
minus sa.
sa. Correct.
Then you were saying some.
Yes. So since this t minus a is there, we are used to f of t, no, inside the integral.
Correct.
Let us just use another variable tau.
Oh.
And we'll say that is t minus a.
Tau?
Tau. Correct.
Is equal to.
T minus a. Then what happens? Now we have this. This is f of tau. This is e power minus s tau. We have to find out dt. Oh, d tau is dt, no? Because
so
a
you
is
are
a constant.
differentiating both
I am
sides.
differentiating both sides.
Okay.
Because a is independent of time.
Correct.
Now we have to be careful. The limits of the integration will also change. When t is a,
When t is
a, tau will be 0.
a minus a.
A minus a. And when t is infinity, tau will be infinity. So the limits of the integral will also change.
It's not that straightforward. I mean, it is once you know it.
Once you know it.
So e power minus sa. A becomes 0 now.
A becomes 0 now. Yes, correct. The lower limit becomes 0.
This is
Infinity.
and f of tau.
Yes.
E power minus s
Tau.
d2.
D tau.
Also, this is
Just a Fourier. It's f of s.
So e power minus sa
F of s.
f of s. So as long as we have this equation, it is f of s.
It is f of s. That is
Can be
the
t or
tau or
some
any
other
variable.
variable.
Yes, it can be any variable. So in electrical engineering, we want to go from time to, we want to apply the transform
yeah.
and go to the s domain. Somebody else may want to do displacement, somebody else may want to do it. Could be any variable.
Correct. And it's an equation. It doesn't know whether it is time or
Exactly.
tau, whatever.
T is just a variable as far as the mathematics is concerned.
Okay, okay. So f of s is getting multiplied by e power minus sa.
Yes.
When you have it,
F of t minus a, u of t minus a.
when you have an f of t which is time shifted.
Time shifted, correct. Shall we add that to the...
Yes. So e power minus a is f of s. Did we do this before? I mean, when we solved something, so I think for u of t minus a.
Yes, I think you are right.
Yeah.
For just u of t minus a, we got e power minus as by s. Isn't it? Something like that we
Correct.
got. Is that
because
correct?
for u of t, it will be 1 by s.
Correct. U of t will be 1 by s.
That's
Is that correct?
That's correct. That's
Okay.
correct.
Okay.
Oh, so if this property was known to us,
We could have used
could
it
have used
there.
it there.
We could have used it there. Correct.
nice. So our transform table is
It's getting longer and longer, right?
yes, yes,
So
yes.